If you are new to or confused about Terragrunt, this video is for you. Why should we use Terragrunt when we have Terraform? Terragrunt is a wrapper that works with Terraform. Let's understand this concept using illustration. If you check Terragrunt documentation, it will say it supports the dry concept. Dry means don't repeat yourself. For example, we want to manage infrastructure across 3 environments: dev, test, and prod. Inside each environment, we will use multiple resources. For example, VPC, EC2, RDS. In this example, we want to configure provider and S3 backend at each and every environment level. In this case, 3 times: dev, test, and prod. We are repeating same configuration across multiple environments. Code duplication causes maintenance issues. This problem can be fixed using Terragrunt. We will declare provider S3 backend configurations in one place and inherit those configurations across multiple environments, that is, in our case, dev, test, and prod. The primary benefits I have observed in Terragrunt are it manages multiple state files. I like this approach because let's say we have large infrastructure, we are introducing a new resource. With Terragrunt approach, I can provision only this new resource without disturbing all existing infrastructure. Provisioning will be fast because Terragrunt will not analyze the entire state file, the entire infrastructure. It will have separate state file for this new resource, so provisioning will be fast and reliable. Why it is reliable? We are not disturbing the existing infrastructure. This is the primary benefit I have noticed. However, Terragrunt provides the flexibility to run apply command at any level. You can run it at a specific resource level, environment level, or even at a project level. Let's start the project setup. I'm creating a folder tg-project, cd into it. Open Visual Studio in this. We will have 2 folders. One is for reusable modules and other one is our actual project where we use those modules. Let's create them. I'm naming it infrastructure-modules. This is where we write modules. In real world, modules can come from Git. One more folder, infrastructure-live. In live, we're gonna use modules and provision resources. Our Terragrunt files will go inside live. Okay, let's create our first module inside infrastructure modules. Create a subfolder. I want to create VPC module. Inside VPC module, the basic file name conventions are main.tf. This is where the resources are written. Outputs.tf if this module returns outputs. Variables.tf if it takes inputs. Let's create those files. In main.tf, let's write resources. AWS_VPC. Let me name it main. Cider block. I don't want a hard code because when this module is called, I want the caller to give inputs. Var dot VPC cider. Let's declare this variable in variables.tf. Variable name. If you want to give default value, please go ahead and give it. In sense, right? When this module is called, the caller can pass this VPC CIDR. If he is not passing, this default value is considered. I do want to configure tags. I don't want to hard code. I want that to be a variable. Let's configure this in variables.tf. I want to define type. Let's have default just empty map. Along with VPC, I do want to create subnet for this example because I want to show you how dependencies work. After VPC module is created, later we will create EC2 module. Their subnet ID is required. So to create that kind of dependency situation, I want to create subnets also. Here our focus is not learning Terraform. Our focus is how to use Terragrunt. So let's keep it simple. Resource subnet, resource name I'm giving main, VPC ID. I need to get the VPC ID from here, dot ID, cider block, let's make this a variable. I'm giving default value, meaning when VPC module is called, all variables are, not mandatory in this case. If caller is not giving all three variables inputs, our module creates VPC with default values configured in variables. Let's also have tags for subnets. Var dot subnet underscore tags. Let's name variable like this. Let's copy paste. Name of the variable is subnet underscore tags. After this module is provisioned, we need to return outputs because after VPC module is created, we are going to create EC2 module. In EC2 module, we want to use subnet ID, correct? So this module should return outputs. Output. Let me return VPC ID and subnet ID. Value. Resource type, name and ID. Likewise, subnet ID. Subnet underscore ID. Now VPC module is ready. Like I pointed out earlier, modules can be in a separate Git repository and we can have just infrastructure live calling those modules. But I want to keep both in same repository so that it is easy for you guys to understand Terragrunt concepts. We want to have two environments, dev and prod. Let's create those folders inside infrastructure-live. Dev for provisioning resources in dev environment, prod for provisioning resources in prod environment. See, this is where the Terragrunt comes into picture. Now let us set up Terragrunt related files. I want to have one terragrunt.hcl file inside the project root. So here create a folder. I'm sorry, it is not a folder, a file, root.hcl. Remember, Terragrunt files must have extension HCL. We should have root.hcl inside infrastructure live. Yeah, it should be here, not in the main project folder. We need to configure provider details. So in this case, assume dev is one Terraform project, prod is another Terraform project. In that case, we need to configure provider details 2 times, right? 2 times. So that is where Terragrunt will help us. We don't need to write same configuration again and again and again. That is what the dry concept in Terragrunt. Don't repeat yourself. If you have a configuration file, don't copy paste same thing across multiple folders. So let's go to Terragrunt documentation to generate provider block. So keeping that provider block generation in root.hcl, we can reuse it across multiple environments, even multiple accounts, multiple regions likewise. Terragrunt generate provider, this one. Let's copy this, paste it here, generate provider path, name of the file it should create or generate. If exists, overwrite. Even if this file exists, it will overwrite when we do Terraform apply or Terragrunt apply in future. So inside this provider.tf file, it's going to generate this content. So specify your provider block details here. I want to keep this in AP South 1. I don't want to provide version and allowed account IDs, nothing. I want to keep it simple. See, in future, if I execute the code for dev environment, this block is automatically generated. If I do in production, again, this provider block is automatically generated. We're writing once and Terragrunt is taking care of generating that wherever required. The next step is configure remote backend, that is S3. Again, considering dev prod as 2 different projects, you don't need to provide backend configuration 2 times in this case. Put it in root.hcl, it takes care of it. And coming to the file name root.hcl, earlier we used to have terragrunt.hcl. Now Terragrunt documentation is suggesting to have root.hcl as a name, but to be honest, file name could be anything. Let's copy this code. Let's create S3 bucket for this example. Create bucket. I'm trying to give unique name for the bucket. Create. Copy the name. Provide it here. better to have terraform.tf state. The bucket region must be provided here. Bucket region is AP South 1. Let me not have encrypt DynamoDB table, these things. See, providing DynamoDB table name will enable state lock, but let me not have it here. Later I will explain what this function does, but for now ignore it. Followed by, we need to have this block. See, we need to generate remote state backend block like we did for provider. The file name is provider.tf. While generating backend file, the file name is backend.tf. We're done with provider configuration as well as remote state configuration. Now let's create VPC by calling the module we have written. I want to provision it inside dev. So go to dev folder. There, create terragrunt.hcl file. See, I'm not going to write main.tf, variables, outputs, these things again. I'm going to simply call the module. So in this case, the syntax to call a module from Terragrunt file is Terraform block, inside that source, and provide the location of the module we want to use. Now we are inside dev. Go one directory back. We are in infrastructure live. Again, go one directory back, right? So one more directory back. Now infrastructure modules. /VPC. I want to pass inputs to this module. Terragrunt supports inputs block. It should be inputs equals. It takes inputs, right? VPC cider. I'm talking about these variables. VPC cider. If you want to provide your own cider blocks for provisioning VPC module, then provide inputs. Likewise, subnet cider. VPC tags. Likewise, if you want to pass subnet tags, provide subnet tags. Subnet tags. Now we want to provision this dev environment resource. By the way, there is one small change. I don't want to keep Terragrunt directly inside dev. Inside dev, I want to have one more folder, VPC. Inside VPC, I want to keep terragrunt.hcl. And one last thing, we need to use include function in terragrunt.hcl file, which is present inside dev/VPC. Let me put it in the top. The idea is simple. If I run terragrunt apply on VPC, we need provider blocks and remote backend, S3 backend configurations required. This include tells find root.hcl in the parent folder. It will go and see in dev. From dev, it will go and see in infrastructure live, there is root.hcl. From there, it will use provider blocks and S3 backend configuration. Let's provision this resource. So we need to go inside infrastructure live, dev, VPC, Terragrunt init. There is some syntactical issue. I did not close the string here. Here also. Do terragrunt init. Remember, we are not using Terraform commands directly. We are using the wrapper terragrunt commands. The next error, it's not able to find this folder. Okay, let's figure out. There is typo issue in the folder name. Let me rename it. Do terragrunt init. Let's see what is going wrong again. I'm checking if provider block is properly configured. This should not be a problem. Let's try Terraform apply and see what happens. It is same. Let's see this. Terragrunt generates provider blocks and remote state backend inside a cache. Let's go there. Backend, bucket, key, region, right? Provider is also looking good. Is something wrong with Terragrunt? Let's check AWS credentials here. It is there. Use S3 LS. That is also working fine. I found it. In remote backend, there is a space in the region name. Yeah, let's fix that. Let's do terragrunt init. Yeah, it's working now. Now the initialization is done. Important thing to notice, we are running terragrunt apply inside VPC folder. Remember, in this we have terragrunt.hcl, which is calling a module, passing inputs. Remember, we have backend and provider configurations in the project root that we are bringing here, or we are reusing it. So what happens after you do Terraform init or apply? Terragrunt generates one cache folder. See this inside your vpc.terragrunt-cache. In that, you have all the files. See, provider.tf is generated and backend.tf is also generated. So yeah. Now let's provision the resources. Similarly, we can do Terragrunt plan also, but I want to Terragrunt apply. Type yes for the prompt. Resources got created. Let's check in the account. Go to VPC. Your VPCs. Yeah, it is there. Let's check subnets. It is also there. Let's go to root.hcl. I said I will talk about this function later. To know what is happening in this function, let's go and check the state file. Open this bucket and see the path dev VPC followed by terraform.tf state. So here this function is replaced with dev/vpc. We are running terragrunt command from dev.vpc. So we are running from here. So that is used as a key. Here, if I run it from, let's say, prod, it will be prod/vpc, meaning for every folder here, it is creating a separate state file. Let's say you may have one big application having VPC, subnets, databases, so on and so forth. How Terragrunt is organizing all these components not in single state file. It is creating separate state file for each and every module. This is really an advantage because when you have a very big infrastructure and you want to make a small change, you apply in the root, Terraform will consider the plan for entire project, which can take a lot of time, and then go and makes the change. So not only that, so when you do apply on entire project, there will be a panic, something can go wrong some other place. Now in Terragrunt, the advantage is you can go and provision only a specific resource without disturbing the existing resources. Likewise, I want to provision same resources in production. So for that, let me copy paste the code. Go to prod, create a folder VPC inside the prod, create terragrunt.hcl, paste the code, include remains same, invoking a module also remains same. If you want to give different inputs, it's your choice. Let me change it to 21. Let me call this JHC prod. For subnet tags also, let me give same. See, I did not write the code again. I'm simply calling the module. Now cd back, one more folder backwards, cd into prod, cd into VPC. Let me ls, Terragrunt file is there. Now I want to apply changes for production environment. I'm doing it from VPC folder. Terragrunt. So you don't need to really run Terragrunt init. Terragrunt apply will automatically perform Terragrunt init for you in the background. So if you think production and VPC is a separate folder and separate project, we do need provider blocks, S3 backend configuration blocks. We are not writing it again. Rather, we are including those configurations from the root. Let's do Terragrunt apply. Enter yes. Resources are created. Now I want to cover how dependencies work. For that, I want to introduce one more module. Let's go into infrastructure modules folder. VPC is there. Let's create one more folder, EC2. Under EC2, I want 3 files, main.tf, variables.tf, outputs.tf. Let me go to main. Let's write a resource AWS instance. I'm naming it main. Instance type, let's make this a variable var dot instance type. In variables, variable name of the variable, let's use default value T3 micro. If caller is not giving instance type, our module uses T3 micro as a default value. We need to specify which subnet it should go inside. Subnet ID, let's make this also a variable, that is subnet ID. I can't give default value because I can't give any random value as a default, so I'm leaving it, which means subnet ID is mandatory. In the outputs, after EC2 is created, let's say I want to return instance ID value AWS underscore instance dot main dot ID. Okay, ID. We are done with EC2 module. Now I want to provision this in development first, then production. So after dev, create a folder EC2. In EC2, we need a Terragrunt file. I copy pasted it. Root include is same. The source of module is EC2. Inputs are different, right? Oh, I need to provide AMI also here. I forgot about that. Var dot AMI, 3 inputs required for provisioning EC2 in our example. I'm not giving any default value, which means this is mandatory. Go to dev Terragrunt. Subnet ID. I'll explain how to get this. Instance type. Let me go with T3 micro itself. AMI. Let me get one AMI ID from AWS account. Go to instances. There is one instance with me. Copy this AMI ID. Make sure the AMI ID is also in same region, which is Mumbai. That's the region we are using in our Terragrunt. Give it here. Now subnet ID. Subnet ID must come from VPC module. So here VPC module is a dependency. To handle dependencies in Terragrunt, let's see what to do. Yeah, so we need to declare dependency block like this. So dependency, any random name, but keep it relevant. The configuration path. So this must be the configuration path of the VPC. Let me copy paste this. And remember, don't provide path to the module, provide path to the Terragrunt. It should be live/VPC. In dependency block, we are pointing to Terragrunt file in VPC folder. I need to get VPC ID from a dependency. Dependency.vpc.outputs. Go to VPC and see the output name, subnet ID. So this is how dependencies work. Now let's provision this resource. Open terminal. We are inside prod VPC. Let me go back. Dev EC2. Yeah, there is Terragrunt file. Terragrunt apply. Something wrong. Okay, there is a problem here. Yeah. There's one more problem. It says you attempted to run Terragrunt in a folder that does not contain terragrunt.hcl. It is there, right? Probably the config path is not correct. So we are in EC2. So go one directory back. It will go to dev. From dev, it should be VPC. // followed by VPC. Let's type yes. There is an error. The subnet ID VPC. Okay, in place of subnet ID we are returning VPC ID. That is our problem. So go to the module, VPC module outputs. Oh, this is our mistake. Right, and do apply. Type yes. Okay, it is still saying VPC ID itself. So what we can do is we can delete the cache of EC2 because looks like those values are cached and it is using same even though we are changing in the module. Type yes. Still we are getting same issue. Okay, let's check in VPC cache. In VPC cache, the code is still pointing to VPC ID itself. Let me delete VPC cache also. Center S. Oh, it is still giving same one. Let's check in VPC cache again. Let's run terragrunt apply on VPC after removing cache and see what happens. Yeah, now it is giving proper subnet ID. So come back to EC2. Let me, for the safer side, delete cache of EC2. Do terragrunt apply. Yeah, perfect. It's successfully created. See, if you observe, we are doing terragrunt apply at specific module level. Let's say in future, you want to do terragrunt apply for entire dev environment. It is possible. Come back, stay in dev folder, use terragrunt, run all command. It will find all terragrunt related configurations in subfolders and apply everything. See that it found 2 units. In the context of terragrunt, unit means one terragrunt.hcl file. It's asking me whether to proceed. I'm saying yes. It is not re-provisioning them. It will find the state files in the units, the subfolders, and it is already matching with the real world objects, so it does nothing. This is what I want to cover part of this video. Thank you so much.